Hello.
There we
It looks
go.
good on my side. Thank you.
Yeah, now we've got it.
Yeah. So what you're seeing is the config screen for my router sitting right next to me, and on there, when you look for the packages they can install, you see BOINC, and that is what we've done. We've introduced BOINC to regular routers as you all have them in your home, and the project allowing that to do so is OpenWrt. It's used for a series of hardware. I have an overview on the next slide, but imagine it to be a complete Linux, uses just a few megabytes of flash space, and it's so embedded that the main purpose is that you don't see that it's running. It's across lots of processors, and typically you use it whenever your router that you already have, basically it's just fine, but the software is not up to today's developments, but not longer supported. So you just overwrite the regular flash with an update, which is an OpenWrt. Also, where I come from is the community Wi-Fi networks, or WLAN networks, as we say. So like when the neighborhoods get together and want to communicate between themselves or their visitors. And whenever you need a web server or your family wants to have some data storage shared for videos, OpenWrt comes very handy. Like you can attach any hardware to it. It's basically running all the time anyway. And you see it often in meta distributions like Promox that takes nukes, so any small Intel machine, and has a series of virtual images ready that you can then install for different tasks, much like those that I've just listed. So machines right at my desk are something like this, a small switch, which has nothing special, but it runs OpenWrt. This is my Linksys router. They promote it to be very kind of open source friendly. But there's also something like Zinc, the Xilinx boards that have a little FPGA attached to it, which some of you know is close to my heart. And behind the Zoom window, you see that it's these devices can be stacked. They're small, and the typical kind of arrays is what you might want to look into. They have a database for you to check your own devices that you have, if they're compatible, and you can install BOINC now. So the motivation why is, well, they're appealing. There's no noise, just all passively cooled. It's just basically a fifth of a performance of the kind of regular machine that you have, but it's no overhead basically. Then, because of the general kind of advancements in the fields, also of the small media units that you have in cars and everywhere, in families, or also in TV stations, these getting better all the time. Energy efficient, and you can attach things to it. We attach here a bit of storage. I mentioned also in the next slides. As a hurdle to overcome, you can have big data, and via PCIe also you have basically no limits on what the machine can really do. For the porting, there was not too much of a challenge, really. I just had to kind of look into configure a bit, send a few other patches that have part been accepted, but there was no general hurdle, except that it was just minimal. There was no X interface. And since we don't want to write to the internal storage too often, which is not liked from the technology, we need to have some extra modules to it. So you need the SATA USB sticks. And there's another thing, we don't have any like GUI to it. So we need something for the regular users that is web-based. And we have developed that, as mentioned in the further screen. So the Lucy interface that you see at the start that configures those routers, we have a BOINC interface for that. For the maintainers of projects, it's a bit different. It's not too different. The ARM executables also run on those small machines. But if you have MIPS or PowerPC routers, you're unlikely that you want to kind of just support them as an extra. The main observation that you will make is that it uses not the GNU-C library, but the Mussel library, which is just as fine. And if you have something statically linked, then it just runs as it is because it communicates with the kernel directly. but otherwise it won't run. And that is why we have decided not to use the typical ARM, star, Linux, GNU, EBI as a platform marker, but we mentioned OpenWrt explicitly, so that no one kind of registered with the project and just gets lots of work units that will then fail. So from the user side, it looks like this. You have the platforms here, and down here to the right to see that there's, do you see my Zoom screen? I hope not. That we have about 10 gigaflops, just a few machines, but it's just online for basically 2 weeks that we have this. So we couldn't expect too much. So far, we didn't get any numbers on the number of installations from TNGrid that we mostly run. Oops. Sorry. Yeah, this is the TNGrid original site. So see, it just has increased from 10 to 11 over the last week. Okay. So when you look at your own kind of status reports, it looks like any irregular machine, but you find a gap here. For 7 days or 5 days, it wasn't computing, and I didn't notice it. It's just because the machine just looks normal. And if something goes down, it doesn't go up again, like this day was the USB storage, then there's nothing warning me. And so this is kind of weird, because you just don't use the machine, it's just all embedded. The machine details look just like always. This is the name we gave it from our local wireless. So it runs the Wi-Fi community network software, and I just attached it to it. That's the name it has here. And the operating system is Linux OpenWrt. The processor is an ARM. So everything integrates just smoothly. This is now the web interface for the configuration. You see there are 2 cores active, or there could be at least. There's just one now. And you have graphical interface that Christian has just recently also completed, and I hope we upload this soon. So this is not public yet, just the core BOINC package. But you have everything you need to attach the projects and get some actual figures on the progress you've made. Limitations. Well, heat is an issue. If you have no fans and a lot of compute and active Wi-Fi, Christian has added cooler to his model. I'm just fine with the processors throttling down a bit. But this depends on the model that you have, and yeah, so with the other model, I haven't seen any issue at all. But the effect is that the newer model, the other model I have, is kind of paced a bit slower, just 1.7 gigahertz instead of 1.8 of the other model. But it computes more effectively, because it's not throttled. I have not seen any impact on the communication performance. Well, so the workaround for us was that we reduced number of cores that compute by default just to half. That, well, for the 2 core machines that may be reasonable, others may just want to set it up. That's another value. The flash memory is too small. It's just typically like 128 or 256 megabyte. So we add USB to it. And also you don't want to write to it. And the communication between the client and the BOINC server is apparently done not completely independently of the hardware. Even though it should just be kind of shared memory only. Then yeah, if you mount it, you need the NFS drivers, and we also tried not to do too much checkpointing anyway. So yeah, that's what we came up with. I think this kind of works nicely for the majority of users. Ongoing work is that, of course, we have to kind of collect users. Like the more users we have, the more kind of stable it will all get, and the more projects will likely kind of want to support this directly. So far, we use TNGrid with Walter being very supportive. I tested Word Community Grid and Rosetta at home, which both work. And YoYo, yeah, it's coming. I just have to compile the wrapper again. It was not statically linked, but this should happen anytime. Christian, for the Lucy interface, has basically written a small app which just does what BOINC command does, but with JSON output, which would then be auto-parsed by the Lucy interface. So it would be a nice touch to BOINC command if you could have a JSON option to it. Then, well, we've come up with OpenWrt as a separate platform, but maybe that's wrong. When it's a regular Unix, after all, it's ARM, it's just that the C library is not the same. And if there would be kind of impetus to just basically always link the C library statically, then we will be completely compatible. But at the moment, we're not. And also for the statistics, of course, I would have liked to just see kind of separate numbers for our distribution. And maybe others would think along the same, that we should have different counters for Red Hat and other kind of distributions that could basically have their own kind of platform name in a way. So this I put up to as a point to discuss if that is something the community would want as a kind of competition between different user bases, which would then kind of strive the overall numbers of installations. BOINC 2e is something which I just basically started to laugh over the last year that we were working on it. It's a command line interface, which I think is underrated for its usefulness. And my personal pet project is that I want to see programmable hardware attached to USB devices as a start, and maybe then also the better ones to go to PCIe. But many of the problems we have, be it NQueens or optimal column rulers, they fit perfectly also to small FPGAs, and I think we're not exploiting that opportunity here. So I want to thank OpenWrt, our Freifunk community, wireless community, the folks about Internet Home in particular for being around and early comments, Rechenkraft.net, of course, and Gianfranco, Walter, and Willy for all the support and attempts and comments they've given to us. Thank you.